Okay, this is on page 151 of your workbook. It should say 7.3, the Pythagorean theorem at the top. Um, so a little bit of history, a little bit of how something was developed in math, and something that is used a lot. Not just with us using it this year, but you'll also use it in pretty much every math class you take from now on. Very popular, very easy concept to understand as long as you understand it, which isn't very difficult to do. It's pretty straightforward, pretty easy. So we're on page 151. So first thing, little history behind this. This is Pythagoras right here. He was a Greek philosopher, and he's the one that discovered this. Now, in math, anytime you have a rule, it is called a theorem. Whenever you get into geometry, you're going to start seeing the word theorem over and over and over again. It's just a rule. Okay? So, when he discovered what we're about to go over, he called it the Pythagorean theorem. It's a rule named after him, Pythagoras. So, if we come down to activity 1, okay? This is kind of what he figured out. So part A, it says on grid paper, draw any right triangle. So that's what they've done right here. Label the sides A and B, the two shorter sides, and then label the longer side C. So that's what they've done right here in this picture. Okay, for part C, it says draw squares along each of the three sides. So they've just kind of shifted the triangle over here, and they have drawn squares on each side. Okay, so notice like this shorter side is 2 units. So to make a square, they made 2 by 2. Okay, this side that was labeled B was 4 units long. So to make the square, they had to go 4 units by 4 units to complete that square. And then the same thing with C. Okay, and then it said label the areas of those 3 squares as A squared, B squared, and C squared. So what that's showing, if you find the area of a square, you know you take length times width. And if it's a square, they're the exact same. So if this is A, that means that this side will be A also. A times A is where they get that A squared. Now, we're not going to do this next part, cutting. But what I want you to notice, and they've done some rearranging with the squares and putting everything together, but what I want you to notice is the square made out of side C is the biggest, okay? The sides for A and B are smaller, and if you were to try and fit these two squares, the A squared, the B squared, if you were to kind of rearrange them and move them around, they would fit perfectly inside this square labeled C squared. They would fit perfectly. So what he decided, or what he came up with, was his formula. And we are going to, down under E, we are going to write this formula. So this is called the Pythagorean theorem. And the formula is A squared plus B squared equals C squared. If you take the two squares that were labeled A squared and B squared and you put them together, they would match up exactly and be the exact same size as that square labeled C squared. Okay? Now, a couple things that you need to know about the Pythagorean theorem. Very key points. First thing is this only works in a right triangle. It cannot be any other kind of triangle. It has to have a right angle in the triangle. Okay? A and B are the sides that make the right angle. And then the last important note, and we'll define these actual terms later, but C is going to be always be the side that is opposite the right angle. So what we're going to spend some time doing in this video is figuring out in a right triangle which are sides will be the A and B and which side will be the C, because it is very important that you get those right, because if you don't have those labeled correctly, then you'll end up getting the wrong answer and it won't work. Okay? Okay, so we're going to flip over to page 152, the next page. Okay, and for activity 2, it says use a ruler to measure the longest side of each right triangle. I'm not going to pull out a ruler and do this. It'll be hard to do on the video, but if you were to do that, if we were to use our formula, and I'm going to write the formula right up over here, a squared plus b squared equals c squared. Okay, your longest side is always going to be C, and remember that that is opposite from the right angle. So I'm going to go through and I'm just going to label these C, opposite the right angle, and then I'm going to use this formula and actually plug in the numbers and figure out what C would have to be. Now, as long as you know which side C is, A and B don't matter. Okay, I could make this side A and this side B, or I could make this side A and that side B. It doesn't matter. So I just start plugging numbers into my formula. So A squared. So let's say I make this side A and this side B. So I would have 4 squared plus 3 squared equals C squared. And that's what we're trying to figure out, is what C would be. And then we just start to solve this. 4 squared, well, 4 times 4 is 16. 3 squared is 9. 16 plus 9 is 25. Now, 25 is not your answer, because that's not what C equals. That's what C squared equals. And remember, to get rid of the squared, we take the square root. So the square root of 25 is 5. So the length on this would be 5 centimeters. Okay? Same thing on B. I'm just going to plug these numbers into the equation. So I have 2 squared plus 4.8 squared equals C squared. And then solve it. 2 squared is 4. Let's see, 4.8 squared. Well, 4.8 times 4.8, 8 and 8 is 64. 8 times 4 is 32, plus 6 is 38. Bring down to 0. 4 times 8 is 32, and that would be 16 plus 3 is 19. I need 2 decimal places, so you get 23.04, and that equals C squared. Add these together, you get 27.04 equals C squared. And then remember, I don't care about C squared, I just want to know C. So we need to take the square root of 27.04. So if I pull out my calculator here, and I take 27.04, square root it, you get 5.2. So my length of C is going to be 5.2 centimeters. Okay, so again, it's just a matter of plugging numbers into the equation and solving it, but you have to know which side C is going to be. That's always going to be opposite from your right angle. Okay. Now, moving on C and D, if you notice, each of them have fractions, okay? You could turn those into decimals if you wanted to, so instead of 1 1/4, I could make that 1.25, and instead of 1 1/2, I could make that 1.5. It's going to be the same process either way. So notice that again, the side we're missing is the side that is opposite the right angle. So that's going to be C on both of them. And then to just set up my equation, remember a squared plus b squared equals c squared. So 1.25 squared plus 3 squared equals c squared. Okay, 1.25 squared. So if I pull up my calculator again, I have 1.25 times 1.25. You get 1.5625. And then 3 squared is 9 equals c squared. Add these together and you get 10.5625 to equal c squared. And we just need to take the square root of that. So I have that entered in here. Here's my square root button. And you get 3.25 for your answer. Okay, drag my calculator up over here. So I have room to work D. Okay, again, we set it up the exact same way. So I have a squared plus b squared equals c squared. Well, 1.5 squared is 1.5 times 1.5. You get 2.25. I know 2 squared is 4, and that equals c squared. Add these together, you get 6.25. And then again, I need to take the square root of this. So 6.25, square root of that, and you get 2.5 as your answer. Okay, so what you're going to do is you're going to come way over here to page 154, and you're going to complete this entire page as your assignment.